So today we're starting with bivariate data. So bivariate data is when we get two lists of it, or two pieces of information from the source. So for example, if I collected all your heights and weights, so see how I got two pieces of information from every one of you. So two pieces of information from the one data source is like what bivariate data is. So we're going to first look at two-way frequency tables. I think we did a little bit of this anyway when we did frequency tables, but here you can see there's a two-way, there's bivariate data. So if we went to survey people on gun control and whether they were for gun control or against it, and then what sex they were, whether they were male or female. So you can see there's the two pieces of information. And so what we look at, we can put it in a frequency table and we have a look. So if you have a look, there was out of a total of 58 men, there were 32 for it, and there was 42 females served, and there was 30 females for gun control. So we can then change them into percentage frequencies. So, and we'll do that later, and I actually can see it over here. So if you have a look, we've changed them to a percentage. So what we've done there, I've shown you how it's done there. They've taken 32 men out of 58 and times it by 100, and that's how they found this 55.2%. So I've done a little example there. So if you look at these examples, can you see that for female, there's 71% are for gun control. So where compared to males, it's just 55, which is like half, yeah, half and half. So because of that, because there's such a high percentage of females for gun control, we could probably say, using the stats, we'll say there is some association with what sex you are and your attitude to gun control. Because if you are female, you are more likely to be for gun control. So what that means is you don't want the guns out there. So like that's what. So and that's all you have to write. So if you look down here, we wrote from the table, we can see that the higher percentage for females for gun control than males, with 71 to 55, whatever. So see how we've used the stat and we've said that there's a higher one in the female, and then we'll say this indicates the attitude to gun control is related to their sex. We don't have to say why or if there should be or why is there. We're just saying this is what the data tells us. Okay, so that's what we'll be looking at, two-way frequency tables. And that's when you've got a category, you've got two categorical datas really. See how you're male or female there, and whether you're for or against gun control. So what type of categorical data are they? So this is categorical data. Does anyone know? Can you remember? Attitude for gun control, for or against. There's no ranking there really. You can't say like for is better than against. So I would call that nominal, yeah? Remember, there's no order in the category. And sex, male and female, also nominal. Okay, so we're going to be looking at, in the end, this bivariate data. So we're going to have these two pieces of information. So and then we often call them two variables. So, So what we're going to see is, okay, we're going to see a response variable and also an explanatory variable. So the response variable, if you have a look, is on your y-axis. So you might want to make sure that you're saying that's the y variable. And the explanatory is the x on the x-axis. So later on when we do some scatter plots, we're going to see that, and generally that's what we do when we see them. So we need to be able to know and decide which one's which, because it will make a major effect on all of those. So the response variable is the one that you are looking at and you're seeing what's happening to that. So if you have a look at it, the response is the gun control. We're seeing what their attitude to gun control is. That's what we want to look at. We don't want to look at whether they're male or female, do we? We're not, that is independent. Nothing will change their sex. Is that true? You can't change, well, generally. Now you have male or female. So that is the explanatory variable. Now, in your sciences, you call the response variable the dependent and you call the explanatory independent. We used to call that in further. I don't know why they changed it, because you guys are pretty good, because you do it in your other sciences, you could tell. So if you want to remember them like that. Explanatory, though, if you think it's got the X in it, it's on the X-axis. So you might remember that's the independent one. So you'll see later, remember when I talked about, if I talked about your height and your weight, see how your height is pretty much it's biologically decided. It won't change really. So that one, when you have height and weight, height becomes independent, but weight could vary, yeah? But generally, and you'll see your response, which generally the taller you are, the bigger you get, but not necessarily. So that's a good example. So in your first chapters, you're going to be asked a lot on which is try to pick the explanatory and the response. So practice that. If you get a bit stuck, come and ask me and I'll try to explain, so it'll help you with determining other ones. All right, so let's have a look at some more two-way frequency tables, because that's going to be your first chapter. So this was taken from an exam, and it can see that at a police checkpoint on a freeway, vehicles were randomly selected for a vehicle and license check. The two-way frequency table below shows the license type, so whether you're a P-plater or you were a full driver, and what type of car you had in terms of was it roadworthy or unroadworthy. So if you have a look, we've got two categories. You probably, this one, or the license type, is going to be that it's independent. So I would say that's the explanatory variable. And the other one, whether it's roadworthy or not, that's the response. So this one, yeah. So if you have a look at it, if you look at the P-platers, they had 85% of their cars were roadworthy. And if you look at the full licensed people, 87% of their cars are roadworthy. Do you reckon there's a big difference there? No. So what that means is that the type of license you have is not really, we don't really think it's associated with whether your car is roadworthy, unroadworthy. It's not. So this is an example where it is not associated, yeah? And you say that because they're similar stats. Can you see that? So down here, the first question in this was, circle the two of the following words that can describe the variable roadworthiness. Is it categorical? Yes, I would say it's categorical, don't you think? And does it have any order, roadworthy, unroadworthy? No, we'll just go nominal. We can't really rank that and say, what is better or whatever. Like you don't, not a ranking. There's no thing there. So does this data support the opinion that the license type driver is associated with roadworthiness of the car they drive? Justify your answer using appropriate percentages. So what you need, it showed you it was a 2-mark. So here I've shown you the examiner's report and how they decided to mark the kids. So the data does not support. So that once you say that it doesn't support, you have to say yes or no. And because they're similar, remember they're 80 and 85 and 87, it's not supporting it. So you say it doesn't support, and for example, and then you can see they've done that, they've used that stat, so there's not a significant difference, and that's 1 mark. So alternatively, you could have said the other stat because they both got low. But look, let's just use the big one. But there's an example for you. So you have an example of if it's not associated, you can go copy this wording. Can you see what I mean? You don't have to worry about stressing out. You can copy the wording, just change the numbers or change whatever the scenario is. So I believe, oh no, that's okay. We'll do this one. So use the data in table 1 to complete the following two-way frequency table. So what you need to do is, this was in an exam, obviously a recent one, you have to complete it. So I want, of the small cars, I'm going to count the medians. So if you go down, here's the size of the car. So I'm going through the small and I'm trying to find, well, medium and small. There's 1, 2, 3, 4. So I'm looking for medium and small. So is it 4? Is everyone happy with that? Yep, so I'm going to put 4. I'll do the next one. So I want small and low. So 1, 2, 3, 4, 5, 6, 7, 8. 8? Okay, they told me the total was 16. Did my numbers add up to 16 there? Yeah? So that was good. Hopefully I'm right there. So now I'm going to do, Now I'm going to do large and high, I need. So 1, 2, just 2. Yeah, everyone happy with that? Okay, now I'll do another colour, sorry. I'm going to do large and medium. 1, 2, yeah? 2, and change the colour one more time. So, sorry, so we're going to do large and low. Is that what I'm up to? Yeah? 1, 2, 3. Did I? Oh yeah, because they already done the small ones, didn't they? So 3. So how many does that total up to? 7. Now, maybe I cut it off. Probably somewhere they would have told you how much data there was altogether. So how many people, how many cars altogether, if you just look at this, total number of cars or whatever it was, yeah? Total number of cars, how can I work that out? Looking at this table, wouldn't it be these two? Yeah? So that would be 23. Just little things that you can work out. But anyway, when it says, what is the percentage of small cars? So of the small cars. So when they say that, you only want the small car total. So that's the 16. And because remember they're asking for a percentage, remember I always said it's an amount over the total times 100. So the total was the small cars, which is 16. And of the small cars, which one has high congestion? 4 times 100. So that is 25%, yeah? If you have a look, do you see the two numbers they made me use were the ones they gave me? That's so there's no consequential marks. Can you see that? Yeah. So say you accidentally counted wrong, they're not going to make you do one of your ones. So see, in further, there's no consequential marks because they've arranged it so it doesn't work like that. Yeah? On these things. So the table below shows the percentage of students in 2 age groups, 15 to 19 and 20 to 24. I just wanted to tell you to help you practice this. This is categorical data, yeah, because it's an age bracket, yeah? But this one is actually ordinal. Why do I think it's ordinal? Because there's younger and older, isn't it? So I know if you're in that older category, you are actually older than the younger category, yeah? So that one is an example of ordinal. Let's keep going. Okay, so the table shows percentage of students with two groups who regularly use the internet at one or more of the three locations: home, education, institution, and at work. So we're having a look here. So let's have a look. So this age group, I would say this is the explanatory. We can't change that. And this is the response. We're seeing what happens. So if you think about it, with the age groups, do you think, well, if you look at home, the home percentages are very similar, yeah? But what's different is these two, yeah? So I might say the age group is associated with, if you're talking about the education institution, you could use that stat, yeah? And say, well, so let's see what they are asking us to do. For the student surveys, which of the following statements by itself supports the contention that the location of internet use is associated with age group? So it's the one I just highlighted, isn't it? Yeah? Because that's showing there's an association because there's a major difference there. Yeah? So we look for that and they need to compare that. So 85% of the students, so now we're looking for a good statement, of the students aged 15 to 19 years use the internet at the education institution. That's not a good one because it's not telling me the other one. You have to compare both. You have to say what the difference is. So can we find that one? Now let's have a look. It says 95% of it at home. Now see, because this one is saying at home and then at work, they're not comparing the same thing, yeah? So we want to compare the same thing and see the two percentages. So someone's just told me it's D, so let's have a look. The percentage of students who use the internet at educational decreased from 85 for those, yeah, that's a perfect little statement there. That one supports it. And now can you see, because they're both at the education institution, yeah, where the other ones you would have seen they're always a different, it's a different spot. So if you look here, this one said home, this one said education, they're different. And the last one would have said home and, and the home, this one is like using the both of the same thing, but it doesn't support that it's associated because they're the same, yeah? So this one doesn't support it because they're the same percentage, all right? Good. Okay, let's do a couple of others. The table shows the information of about a particular country. It shows the percentage of women by age at first marriage for the years 1986, 1996 and 2006. So, of the women who were first married in 1986, so they want just these women, what percentage were aged between 20 and 29 years? So what percentage was it? There, thank you. All right, so of the ones first married in 1986, 20 to 29 is, we need both of them, don't we? Yeah? So you're going to add those two because we need to go from 20 to 29. So we're going to add 42.1% plus 23.4%. And what will that equal? 65.5%. Awesome. Okay, does the information support the opinion that for the years 1986, 96 and 06, the age of women at first married was associated with the year of marriage, so how old they were? Justify by quoting your appropriate percentages. It is sufficient to consider one age group only. They were nice to help you out there. So you only have to do one and use the same. So is there one that's really different? I would probably go with, I might say, I'd go with this one, yeah? And I'm going to say, yes, it is, because it's increasing, yeah? So I'm going to say, yes, the age of a woman at first marriage, at first. Marriage is associated. Okay, so we can change these percentage frequency table two ways, and we can put them in these segmented bar charts, which we had seen. So obviously they're a great way to represent it, because this table doesn't really sing out to me. If I was presenting it to a boardroom, it's just numbers. It doesn't, for those visual learners, it's no good. With this, when you've got it like presented like this is great, because straight away I can see there's a major difference in the female and male, can't I? I can see this box is this pale box 4, so that's the gun control, so I could see it. Down here we've got another one, and we've got multiple categories, and this is the education level. So see how it goes year 9, year 10 to 11 and that's categorical, and that is ordinal, because we're going up in an order there. So just so you can practice. Smoker and past smoker, never smoked, that will be categorical, but that's actually nominal. Yeah, there's actually, I know that, I'm pretty sure that's nominal. I know it's got 3 categories, but I'm going to say no. Okay, so if you have a look there's all the table. If I had to write a report on that, so see how your education level is university, and if you look down here, the university, if you're a smoker, is that blue colour on the bottom. So see how the higher your education went, the less there were of smokers, yeah? People who had, who smoked. So you could use that, and we had an example here, so you can see. From the table we see the percentage of smokers clearly decreased with education level, so we're talking about this little pocket, and we went and used these stats, and we went from 33.9% for year 9 or below to 18.4% for university. I think you probably should quote all of them just to be safe. See, I should have... a study was conducted to investigate the number of moths caught in a moth trap. So you had less than 250, 250 to 500, and 500. So this is categorical data, and it is ordinal, yeah? Because you've got a thing there. This is categorical and nominal. Categorical and nominal. So no order there. Okay, so there were 300 sugar traps. The number of sugar traps that caught less than 250 moths is closest to. So if you have a look, we've got to go in the sugar trap one, and we're looking for less than 250, which is the white box. If I look at the white box, that is 30%. So 30% of 300, what would that be? That's easy. Yeah, it is 90. Good. Okay, so just got to make sure the biggest mistake with these things are just people reading the wrong category. So do what I just did then. Make sure you're highlighting, going sugar, sugar, whatever you want. Okay, the data displayed in the percentage segmented bar chart supports the contention that there is an association between the number of moths caught and the moth trap type, because now we're looking for something to compare. Now you want to compare the same category, so we're trying to look for something where they compare the same one. Now, so let's go, I'm not even looking at the first one, they don't have enough writing. So the percentage of sugar traps containing more than 500 moths is greater than the percentage of scent traps containing 500 moths. I don't mind that, because they've both compared those ones, yeah? Because they said sugar and scent, and there is a bit of difference there. Let's see if the other ones, see how these ones are comparing 500 moths to 250, so we're not comparing the same category, and the sugar traps, 20%, well now wait a minute. So what about this one? There's 20% of the sugar traps contain more than 500 moths, while 10% of the light. So what category is that? Light traps and 500. More than. So this one's okay too. Wait a minute. Why is this one, other one not good? Why I like this one is because it's greater than the percentage, where the other one down here, although it is comparing 20% of the sugar traps contain more than 500 moths. So that's 20%, that's correct.
Would it be because it says less than 500 moths?
And contain more than 500, 10%. Well, that one's all right too. So this one's actually two different categories. Yes, that's what you're saying. So which one? This one's the best answer, yeah? Yeah, good. Sorry. See how they're very hard. They're very similar. The words are very similar, but you're looking for that. God, I'm tired. Okay, question 7. The variable numbers of moths less than 250, 250 and more than 500 and trap type, sugar scent are both, we've already done this. They're both categorical, but one is, this first one is ordinal and the next one is nominal. So, ordinal and nominal. So I'm going to go this one. When it says respectively, it means what they mentioned first is what they're stating first. Okay? So because they mentioned this one first, which was ordinal, I put ordinal first, yeah? And the next one was nominal. So go with that. Okay, so for significant figures, what you do is once you get a non-zero number, that's when you start counting. And then once you are counting, all numbers are significant from that point on. So if you have a look, so in this example, if I had to round this to 2 significant figures, you can see I start counting straight away because that's not a 0. So 1, 2. So once you've got to the 2, you have to look at the third and decide whether that second one would be rounded up or rounded down. So because it's a 7, it rounds up to 4. So you can see 2 significant figures would be 94. When we're asked to do 1, so we get to 1 significant figure, we count on the 9. Okay. So if I just wrote 9, is that an indication of what that number is? It isn't it? No? It's 90, not 9. So can you see when you are this side of the decimal place, so up in the units, once you have your significant figures you put a 0 until you get to the decimal point. So because we only had to do 1, we're going to say 90. Okay, and then 5 significant figures, you can see we've counted up to 5 and we've looked at that, and so we've written that one. So if you have a look here, if I had to round this one to 3, I don't start counting until I get to the first non-zero. So there's 1, 2, 3. Now because that guy's a 5, it went up to 4. So I just will do a couple more just so you know what I'm talking about. If I had example, and this is what you'll get, things like 12,695, okay? Say it was dollars or whatever. And they said round that to 2 sig figs. So if you look at it, I'm going to go 1, 1, 2. That's a 6, so I'll go 1, 3. Now, I can't just leave it at 13. Say that was 0, 0. It was money. Because that's not 13. We're rounding it to 13,000, aren't we? So can you see what I mean? You got to put the 3 zeros until you get there. All right? That's only on that side. If you're in the other side of the decimal place, it wouldn't make a difference, yeah? If we put zeros here, does it make any difference? No. No, so it doesn't change the value where it does on that other side. So yeah, you've got to make sure you do that. All right, so you're going to see this because you're going to get big numbers and they don't want you to use it. They just want you to round them. So there. So here's an example in the exam of one that they got you to do. So here's a formula. We're going to get these in a minute. Like we'll be doing these equations. And they've asked us when the numbers of the equation are correctly rounded to 3 significant figures, the equation is. So that'd be 1, 2, 3. Now, because that's an 8, that guy's going up. So what would that go? That means it goes to the here, which is 3. So that one's going to be 43.0. You need the 3 figures. So it's going to be like that, okay? This second one, 1, 2, 3. Do I have to round up? No. So it'll be 0.877, yeah? And so which one will be that one? E? Yeah? Okay, and that was the answer.